Hello everyone, welcome to this lecture on engineering physics. In last class we have studied about what is coherence and what are the various types of coherence and till coherence time we have discussed. Okay, so this lecture we are continuing the concept of coherence. We were discussing about temporal coherence. So already we have defined what is coherence time. Now we'll go to bandwidth and other factors. Okay, so basically what is bandwidth? Bandwidth is defined as the interval of different frequencies, or you can say the difference between the two frequencies, say f1 and f2, or the wave or gf. Suppose you have any two waves. Okay, suppose you have a wave 1 है आपके पास में और wave 2 है. It is having the frequency of f1, this is having the frequency of f2. So bandwidth is nothing but it is defined as the interval of the frequencies, or you can see the difference between the frequencies depending on which one is larger. It can either be f1 minus f2 or it can be f2 minus f1. Okay, so basically, or you can define it as df also. Df is nothing but difference of the frequency. Now as we have known what let's see one more note point, that an ideal monochromatic source, we all know that कोई भी एक आइडियल मोनोक्रोमैटिक सोर्स होता है वो क्या करता है, दैट एमिट वेव्स ऑफ सेम फ्रीक्वेंसी. ओके, आइडियल मोनोक्रोमैटिक सोर्स इज एमिटिंग वेव्स ऑफ सेम फ्रीक्वेंसी. सो दैट मीन्स इन्फिनिट अमाउंट ऑफ टाइम तक जो मेरा फेज डिफरेंस है दैट इज कांस्टेंट. ओके, सो ऐसे फंक्शन को हम साइनसॉइडल भी कह सकते हैं. सो द फेज ऑफ एन आइडियल मोनोक्रोमैटिक सोर्स इज साइनसॉइडल फॉर इन्फिनिट अमाउंट ऑफ time. Okay, that is, its phase is constant, phase difference is constant with respect to infinite amount of time. But in reality, can we have an ideal monochromatic source? No, because see, already you know an atom has a nucleus has an electron surrounding by it. So whenever an electron is excited to its higher energy level, okay, to its higher energy level, there it remains only for 10 power minus 8 seconds, and then it jumps back to its lower energy level. So when it is coming back to its lower energy level, what happens is that some form of energy is radiated outwards. So that radiated energy is nothing but light. So since electrons moves in some time difference, there will be some phase difference. So you cannot say that you will have a sinusoidal for infinite amount of time. So there can be breaks. But if we take a smaller time interval, delta t, say delta t, you are taking this time interval, then you can find that for that smaller time instant, you will get a sinusoidal wave, or you can say the wave with the phase difference as constant. So you can say that a real monochromatic source is emit waves of slightly different frequency. So the phase is sinusoidal for the small time period, that is delta t. Okay. So suppose we have these frequencies, so this is sinusoidal over this period and this is sinusoidal over this period. Okay, so if you are to define, let's say the frequency, this wave's frequency is f1 and this wave frequency is f2. So if you have to define the bandwidth, what you will define is the difference between these two frequencies, or you can say df. Okay, so you can tell that coherent time is equal to 1 by f2 minus f1, or 1 by bandwidth, or you can say that is equal to 1 by df. Okay, so coherent time can be defined as 1 by df is equal to 1 by bandwidth. So from this, what you can actually say, what is coherent time? Coherent time is nothing but see the interval over which the phase difference is constant or the thing is sinusoidal. So that for that time interval is called the coherent time. बिकॉज उस टाइम इंटरवल पे मेरा जो फेज डिफरेंस है वेव का वो क्या आ रहा है, कांस्टेंट आ रहा है. सो कोहेरेंट टाइम इज नथिंग बट इट इज द एवरेज टाइम फॉर विच द वेव इज साइनुसॉइडल, और इट इज द एवरेज टाइम फॉर विच द फेज डिफरेंस रिमेन्स कांस्टेंट विद रिस्पेक्ट टू टाइम. तो क्योंकि हम टेम्पोरल कोहेरेंस की बात कर रहे हैं, सो देन वी से विद रिस्पेक्ट टू टाइम इट इज कांस्टेंट. ओके, now suppose how will you calculate average? Suppose you have n numbers, how will you calculate average? You will add all the numbers and divide by the total number of observation. Now suppose you have waves. Okay, many waves are there. Okay, and you have small time intervals t1, t2, t3 up to tn. So how will you calculate the average coherent time? That will be Ta is equal to t1 plus t2 plus t3 up to tn divided by n. Okay, so the average coherent time can be given by t1 plus t2 plus t3 up to tn divided by n. Also you can write down summation I equal to 1 to n ti by n. So this will represent your average coherent time. Now let's talk about coherence length. So whenever you are talking about length in a case of wave, what comes into the picture is wavelength lambda. Wavelength lambda represents the length. Now you have n number of waves, then it will be n lambda. So you can, if we represent coherent length by LC, then we can write it down LC is equal to n lambda. So distance basically, जो कोहेरेंट टाइम में मेरा जो डिस्टेंस ट्रैवल हुआ है उसको मैं क्या कहूंगा, कोहेरेंट लेंथ. सो डिस्टेंस ट्रैवल बाय लाइट इन कोहेरेंट टाइम और द मैक्सिमम डिस्टेंस बिटवीन टू पॉइंट्स फॉर विच द फेज डिफरेंस बिटवीन देम इज कांस्टेंट. किसी भी दो पॉइंट्स के बीच में वो मैक्सिमम डिस्टेंस जिसकी वजह से मेरा जो फेज है वो कांस्टेंट रहेगा विद रिस्पेक्ट टू टाइम इज कॉल्ड कोहेरेंट लेंथ. ओके, now if you see the equation of speed, time and distance, अगर हम तीनों को देखें कि how are all the three things related. So you know that speed is equal to distance by time. Okay, so from this if we calculate, distance will be what? Speed into time. But in the case of this wave, speed will be represented by the speed of light, that is c, and t time is represented by the coherent time tau. Okay, also we know again from this distance is equal to speed on time. So time will be what? Time will be what? Distance by speed. So in any wave you can define time as equal to lambda by c. So if you are to calculate the frequency from this, the frequency will come out to be c by lambda. Okay, also you know that coherent length is nothing but c into tau. Also we have already defined tau is 1 by df. So we have LC is equal to 1 by df. Now if you have the frequency c by lambda and you have to calculate df by over d lambda. So how will you calculate? Differentiating, since it is taking a by b form. Okay, you will first differentiate the numerator, then keeping the denominator as it is, minus differentiating the denominator and keeping the numerator as it is. So a dash b minus a b dash by b square. So since c is constant with respect to delta, it will become 0. So 0 into lambda minus 1 into c by lambda square. So df by d lambda is nothing but minus c by lambda square. So df will be c by lambda square into d lambda. Okay, now substituting this value onto the equation, you will get LC is equal to lambda square by d lambda. Okay, now let's take one of the question. Find light of wavelength lambda is 4800 angstroms, has a coherent length of 25 waves. Find the coherent time. See, we already know time. Time is nothing but what? Speed is equal to distance by time. So time will be nothing but distance by speed. Okay, distance by speed. Speed of course over here is speed of light, and distance over here is coherent length, that is LC. LC is equal to n lambda. N we have been given as 25, lambda we have been given as 4800 angstroms, and C we already know as 3 into 10 power 8 meter per second. So substituting the values, we will get n lambda by C, and the values we will get is 4 into 10 power minus 14 seconds. So this is the coherent time we will get from this. Okay, this is for this lecture. Thank you very much.